Okay, this is page 2 of your chapter 9 study guide. This is going to start our conversions from rectangular to polar coordinates. So number 7 from the first page is going to be very useful for these next few problems. Number 8 says find the rectangular coordinates of each point. So your answer should be exact. Okay, so for part A, I'm giving you polar coordinates, right? Because anytime you see degrees, or in the other case of example B, you've got pi, so you know that that's a radian. This is r and this is theta. Oh, let me say, okay, 6 is r, 120 is theta. And if I ask you for the rectangular coordinates, I want them in the form x comma y like this. So what we're going to do is use our equations from number 7. We know that x can be found by doing r times the cosine of theta. So if r is 6, then I'm going to have 6 times the cosine of 120 degrees. Okay, so then remember, I want you to give me exact values. So then this is going to be 6 times the cosine of 120. This is again where the benefit of using your unit circle comes into play. If you just look at your unit circle, cosine is the x value at 120 degrees, which is going to be negative 1/2. So then 6 times negative 1/2 is negative 3. So x is equal to negative 3. I have many people ask, oh, what mode should our calculators be in? And because I'm asking you for exact values, it's probably best that you stay away from your calculator altogether and just use your unit circle, because your calculators may actually confuse you. Okay, so there's the x coordinates. The y coordinate is given by r times the sine of theta. So it's going to be 6 times the sine of 120 degrees. So that'll be 6 times, again, using the unit circle, the sine of 120 is the y value, which will be square root of 3 over 2. And then when I reduce this, 6 square roots of 3 over 2, 6 over 2 is just 3 square roots of 3 as y. So your final answer in rectangular coordinates for part A would be negative 3, 3 square roots of 3. For part B, we're doing the same thing. The only difference is that this theta is given in radians, but that doesn't really change anything. It just means you're looking for radians on the unit circle instead of the degrees. So same approach. X is going to equal r times the cosine of theta. So it's going to be 4 times the cosine of negative pi over 4, which will be 4 times. Now, negative pi over 4 is not on your unit circle exactly as it is. So that just means you need to start at 0 and you need to go clockwise pi over 4, which is going to get you, that's going to be the same thing as 7 pi over 4. The cosine at that value is the square root of 2 over 2. And then when we reduce that, 4 divided by 2 is 2. So that's going to be 2 square roots of 2. Similarly for y, it's going to be r times the sine of theta. So it's going to be 4 times the sine of negative pi over 4. Again, negative pi over 4 is the same thing as 7 pi over 4. So this would be 4 times the sine value. The y value there will be negative square root of 2 over 2. Simplify our numbers out front again. 4 divided by 2 is 2. So it'll be negative square roots of 2, or negative 2 square roots of 2. So your final answer in coordinates form, coordinate rectangular form, will be 2 square roots of 2, comma, negative 2 square roots of 2. So this is converting from polar to rectangular. Number 9 is doing the opposite. It's saying determine the polar coordinates of each point. R should be written in simplest radical form. Theta should be between 0 and 2 pi. For part A, I want you to give me an exact value for theta. Part B, we're going to go ahead and round it. So just to mix it up, make sure we know how to do both scenarios. So this time I give you x and y, and we need to find r and theta using the same equations from number 7. So r is the easy one, I think. R is going to be the square root of x squared plus y squared, or a squared plus b squared. So that's going to be negative square root of 3 squared plus negative 3 squared. So be careful here. Negative square root of 3 squared. And anytime it's negative, a negative times a negative is a positive. So we know it's going to be positive. Square root of 3 squared is 3. Okay, plus the square root of 3 squared, or no, I'm sorry, plus just negative 3 squared is going to be a positive 9. So it's going to be the square root of 12, which can further be broken up into, that'll be the square root of 4 times the square root of 3, which the square root of 4 is 2. So r is going to be 2 square roots of 3. Okay, so there's r. Theta is going to be tangent inverse of y over x plus pi. And we're going to use plus pi because, and let me actually fill out what this is going to be because I don't have a ton of room here. So it'll be tangent inverse. Y is negative 3 over x is negative square root of 3 plus pi. And the reason that is because x is less than 0. Our x coordinate is negative. So then we're going to go ahead and simplify this as much as possible. Remember, you have to have an exact answer for theta. So this is going to be tangent inverse. Negative over negative is going to be a positive 3 over square root of 3. But I want also, let me go ahead and, well, I'll write it like this, 3 over square root of 3. But I'm also going to go ahead and rationalize it in the same step. Square root of 3 times over square root of 3 plus pi. So then this is going to equal tangent inverse of 3 square roots of 3 over 3 plus pi, which again, tangent inverse will be 3 over 3 is 1. So it's just tangent inverse of square root of 3 plus pi. So think about what this means. I want to know what value of theta, looking at your unit circle, has a slope of square root of 3. And we want the principal value. So even though there are two answers, we want the answer, since its slope of positive, or tangent is positive, we want the first quadrant angle. Well, in the first quadrant, the angle that has a tangent of square root of 3, and again, this is the benefit of the unit circle on the first page, the square root of 3 tangent in quadrant 1 is going to be pi over 3. Okay, so this reduces to pi over 3 using the unit circle, and then we're adding plus pi. Well, if I'm adding pi over 3 plus pi, pi can be rewritten as 3 pi over 3, right? And then when I add those fractions, 1/3 plus 3/3 pi, I get 4/3 pi, or 4 pi over 3, giving me my final answer in polar points, which will be 2 square roots of 3, comma 4 pi over 3. So finding the exact answer is a little bit more challenging because you have to deal with the algebraic reasoning, especially of the tangent part. Part B is going to be a little bit easier because I'm allowing you to round 100th. So start the same way, finding r. R will equal the square root of negative 5 squared plus negative 8 squared. So it'll be the square root of 25 plus 64, which is 89. And there is no square factor of 89. So that's going to be as simple as we can go for r. Theta will be tangent inverse of y over x. So it'll be negative 8 over negative 5. Plus pi, again, we have to add plus pi because our x value is less than 0. X is negative 5. So because you're allowed to round to the nearest hundredth for this part, you're going to type this into your calculator exactly as you see it. Second tangent of negative 8 over negative 5, or you could do positive 8/5 if you want. Close parentheses and then add pi. Your calculator needs to be in radian mode for this because I'm telling you theta should be between 0 and 2 pi, which indicates we're in radians. So making sure your calculator's in radian mode, you're going to get that theta is approximately, to the nearest hundredth, 4.15. So your final answer in polar coordinates will be the square root of 89 and then 4.14. So that's how to convert from rectangular to polar. Numbers 10 and 11 are similar, except I give you actual equations that I want you to switch back and forth. So there is no, like these these types of questions are predictable because you have to use, you know, the two equations for x and y, and over here you have to use the two equations for r and theta. For 10 and 11, when you just have to switch the forms, there is no clear cut, this is what you do every single time and this is how you get the answer. Here's what I do need you to remember. When you write the equation in rectangular form has, let me write this out here to the side. Equation, let me write it in a different color. Okay. Equations in rectangular form. All x's and y's, no trig. And usually in the form y equals something. Okay. But if there is no y, you could have x equals something as well. But typically y equals something, or sometimes you might have like x squared plus y squared equals something. That's another format that you are allowed to write it in when both of them are squared. Okay, so for A, I've got theta equals pi over 6. Well, I'm using the same equations as number 7. Theta equals pi over 6. So if I use these equations, the only variable that I have is theta, right? Pi over 6 is not a variable. So if the only variable I have is theta, I've got to use one of these equations to substitute something for theta. So I'm going to use, we don't really know what x is at this time. So when you don't know what x is, you can always assume that it should be positive. So instead of theta, I'm going to substitute tangent inverse of y over x using that equation. So instead of theta, I've got tangent inverse of y over x equals pi over 6. Now, we haven't gotten rid of all the trig because pi over 6 is trig, or it's a radian, so I've got to get rid of that. And I want to try to get this in the form of y equals. So the next thing we want to do, since I can't have tangent either, because that's definitely trig, is in order to get rid of tangent inverse, I'm going to do the opposite, which is to take the tangent of both sides. So when I take the tangent of both sides, on the left side, it leaves me with y over x. And then on the right side, I get what is the tangent of pi over 6. Well, again, this is where your unit circle is going to come in handy. We're going to get y over x equals. If we actually use our unit circle, we can evaluate the tangent of pi over 6, which is, we found earlier, the square root of 3 over 3. And then typically we want it in the form, or rectangular form, of y equals something. So the very last thing that we want to go ahead and do is just multiply both sides by x. And in doing so, we'll get our final answer, y equals the square root of 3 over 3 times x, which you could rewrite as like x square roots of 3 over 3. That's another option as well. Part B, I've got r equals negative secant theta. R equals negative secant theta. So you have a couple options. You could notice r, right? Secant is not in any of the equations. You could notice r and say, okay, what can I plug in for r? Well, I could maybe solve one of these for r and plug in x over cosine or y over sine. I maybe could rewrite it as the square root of x squared plus y squared. And both of those would probably help you get somewhere, but I am here to help you get rid of this secant first. Remember, if we're not allowed to have any trig, it's always good to try to get rid of any trig ratios that you may have, or trig functions that you may have. So if I want to get rid of secant, the first thing that we need to recall is what is secant. So if I rewrite this equation to be r equals negative, secant is 1 over cosine. So if I write it that way, then 1 over cosine can be canceled, I'll say, if I multiply both sides by cosine theta. Now, that gets rid of secant, but then what happens is on the left side, I'm still left with r cosine theta is equal to, on the right-hand side, I have negative 1. But the reason I did that was because I'm pretty good at these because I've done them. I knew that if I multiply both sides by cosine, on the left side I have r cosine theta, which in your equation for number 7 is the same thing as x, which means I can just substitute instead of r cosine theta. I know that is equal to x, and then I literally end up with x equals -1. So this is one of the scenarios where you're not going to have y equals or x squared plus y squared equals because you don't have a y value whatsoever, and that's okay. Okay, number 11 is opposite of 10. I give you rectangular equations and I want you to write it in polar form. So to recap over here, when you're writing something in polar form, you cannot have x's or y's. So no x's or y's, and it's usually in the form r equals something else. So for number 11, part A, the only thing that I can do off the bat is change y, right? There's nothing I can do with 2. So if I use my equations from number 7, we know that y is the same thing as r times the sine of theta. And that's going to be set equal to 2. So you've successfully gotten rid of the y, and now everything is in kind of a trig format, but we do want to go ahead and put our equation into the form of r equals blah, 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 blah. So to do that, I want to go ahead and divide both sides by sine theta. And then so you end up with r equals 2 over sine theta, which you probably wouldn't see this written as an answer, just because, you know, we kind of try to stay away from fractions. So this is the same thing as 2 times 1 over sine, right? And then 1 over sine is the same thing as cosecant. So I'd say the most appropriate final answer for this would be 2 cosecant of theta when possible. And I know I didn't write it in your rules over here, but when possible, you do want to avoid stacked fractions in equations like that if you can rewrite the trig function as something else. 11, part B, x squared plus y squared equals 5y. So I have lots of x's and y's to get rid of. The first thing I want you to notice is x squared plus y squared. Even though in your equation we don't have x squared plus y squared isolated, I can get it isolated if I square this side, and then it cancels my square root. And what I do to one side, I've got to do to the other as well, which tells us that x squared plus y squared is equal to r squared. So then you get r squared equals 5y. Now, we still have y and we can't. So r squared is equal to 5 times. Instead of y, we can use our other equation that y is the same thing as r times the sine of theta. So now you've gotten rid of all the x's and y's, but we want our equation in the form of r equals something else. Well, another tactic that you can use is if you have more than one r on each side of the equation, go ahead and try to divide one out. If I divide both sides by r, on the left side, r squared is knocked down to just r. And on the right side, it cancels out with that r, just leaving me with 5 times the sine of theta. So your final answer would be r equals 5 sine theta. Number 12, write the general form of each type of complex number. When I say complex number, the thing that should be triggered in your brain is I. So a rectangular form of that would be either a plus bi, or if you prefer using x's and y's, it would be x plus yi. I would accept either one of those. Okay, the point is, though, it has a real component plus a real coefficient of the imaginary component, which gives us bi. The polar form is r times the cosine of theta plus I times the sine of theta. Or you could abbreviate this if you want as r CIS theta. I don't usually do the abbreviation. I usually write mine out, but that's up to you. Again, these are things that you need to know. I'm not giving you anything on the test. Okay, number 13, solve each equation for x and y where they are real numbers. So the idea here is that you want to isolate or group together your real components on each side of the equation and your imaginary components. So on the left side, real numbers are just going to be any numbers that don't have anything to do with I. So on the left side, it'll be 2x plus y. On the right side, the only real component is 5. So I'm going to set those guys equal to each other. 2x plus y equals 5. My imaginary components on the left side are going to be xi plus yi, and the imaginary component on the right side is going to equal 4i. So the idea of grouping all of the imaginary components together is that if I divide everything by I, then I cancels from each of those terms, leaving us with x plus y equals 4. And then your goal is to take your two simplified equations here and you want to solve them. So that's where you can use substitution or you can use elimination. I don't anticipate that you'd want to graph. So I'd use one of those two solution methods. I'm going to go ahead and eliminate, because if I do that, let's see, I've got 2x plus y equals 5. If I subtract my second equation, x plus y equals 4, if I subtract, then 2x minus x is just 1x. Y minus y, remember this negative is applying to absolutely everything. Y minus y is 0, equals 5 minus 4 is 1. So there's the first part of your answer. X is equal to 1. And then when you plug 1 either into either one of these other equations, if I plug x equals 1 here, then I get 1 plus y equals 4. Subtract 1 from both sides, and I end up with my second answer of y is equal to 3. So my final answer would be x equals 1 and y is equal to 3.